Thanks for the introduction, Caroline. Hello, everyone. Thanks for joining our talk. We are going to talk about function mesh in this talk. And first of all, a little bit introduction. My name is Nenlu, and my colleague is Rifu. We are all software engineers at StreamNative and working on the computing part, like Pulsar functions and function mesh, and other like computing projects integration with Pulsar. So today today's agenda will be like, first I will introduce a little bit about Pulsar functions, and then my colleague Ray will be discussing about Pulsar functions, and at last we will look at the demo. So first of all, Pulsar functions. We know that Apache Pulsar has like support different data processing frameworks, like the three typical categories, including interactive queries like Presto, stream and batch processing frameworks like Spark or Flink. And the last one is kind of a special to Pulsar, is like function processing. And Pulsar functions, they are kind of a lightweight compute processes that can consume messages from Pulsar import topics and then apply a user-supplied implemented processing logic to each of the messages, and then publish this result into some kind of result topic. So an overview of the process we described before looks like this. So the Pulsar functions in center would take input messages from the left input topics and then process that, and then output to the topic 4 as an output topic. And here's a convenient utility called log topic. So if you want to know what's happening inside the runtime, you can just log that into this kind of log topic for debugging purposes. So some of the typical use cases for Pulsar functions, including ETL jobs, real-time aggregation, microservices, and event routing. So some people in the streaming computing area may have questions, or may ask, like, what's the difference between Pulsar functions and Flink, Apache Flink? So to our understanding, the Pulsar functions is a kind of Lambda-style processing unit that is specifically designed to integrate with Pulsar to achieve some kind of simple processing. And it's not another like full power streaming and processing engines like Apache Flink, which you can integrate it with different messaging systems, and you can do some of the very complex semantics like watermark, process time stuffs to achieve the data processing goal. So there's another very special form of the Pulsar functions called Pulsar connectors. They are categorized into two different types, source and sink. Source connectors feed data from external systems into Pulsar, and sink connectors, you will send data from Pulsar to external systems. Basically, they connected the Apache Pulsar project with all the other external data systems like blob store or cloud storages. So the APIs for Pulsar functions is very intuitive and simple. You just need to implement one single method called process and take an input with a context and return the result. So that's all. And here we listed three different languages we supported, Java, Golang, and Python. And for the semantics, Pulsar functions currently support like at least once, and effectively once semantics. And if you are familiar with the Pulsar project, the transaction support has been added into Pulsar as release 2.8.0. And we are also actively working on adding the exactly once support based on the transaction feature from Pulsar. So Pulsar functions, the runtime for Pulsar functions, there are three different types of runtime for Pulsar functions in the Apache Pulsar project. One is thread runtime, which functions are invoked in the function worker thread, and a process runtime. So functions are invoked in a separate process forked by a function worker, and Kubernetes runtime, which functions are submitted to Kubernetes as stateful set by the function worker. So for the deployment, there are two different deployment mode. You can either like deploy the function worker with the broker together, or you can run the function worker separate from Pulsar brokers. And here's the summary. So for Pulsar functions, it increased the developer productivity by providing a very intuitive API and multiple language support. It reduces the operational cost by fully integrate with Apache Pulsar and not require you to set up bare metal like cluster for submitting all those kind of computing functions. And it's also very easy to troubleshooting. You can just run it. You can utilize a local runtime to run it locally for debugging purpose, or you can, as we mentioned before, you can use the log to log what's happening in the runtime. Okay, I think I will just stop here. Hope that I help you understand the Pulsar functions a little bit. And my colleague Reifu will be discussing about function meshes in the following time. Thank you.
So thanks, Nance, for sharing about Pulsar functions and connectors. So let's start with the function mesh part. Here we have to make a Pulsar function one more step, and to ease some pain points and make Pulsar functions much more easier to use. So we combine Kubernetes and the Pulsar functions together to make a serverless framework that run in Pulsar functions and connectors natively on Kubernetes. So we call it a function mesh. And the main purpose for function mesh are firstly, to integrating separate functions and connectors together to process data and accomplish a final goal, processing goal. And secondly, to utilizing Kubernetes native resources and scheduling capabilities. So function mesh is suited for common lightweight streaming use cases like ETL jobs, and it is not intended to be used as a full power streaming engine. Before digging into function mesh, I would like to talk about some pain points of Pulsar functions and why we built function mesh. As Nam mentioned in previous section, that Pulsar functions do have a Kubernetes runtime. With Kubernetes runtime, functions metadata is stored in Pulsar, and the function's running state is managed by Kubernetes. And this may have some inconsistency problem between metadata and the running state. Like the stateful set is running Pulsar functions can be deleted from a Kubernetes API, and the Pulsar do not being notified. Also, the existing implementation of storing function metadata may cause broker crash loops if the function metadata topic are not available temporarily. Certainly, functions cannot be used across multiple Pulsar clusters, and the functions are tied to specific Pulsar cluster. Also, currently, Kubernetes runtime is hard to user to implement certain features provided by Kubernetes, like auto-scaling. Additionally, it is hard for user to manage multiple functions and bind them into a single job to achieve a complexity processing goal. Without function mesh, user needs to do a lot of manual work to organize and manage multiple functions to process the event. So let's talk about the three components of function mesh, and I will firstly go through the Kubernetes operator. In function mesh, we use operator SDK to define several customer resource definition to allow user manage functions, connectors, or mesh as a customer's resource in Kubernetes. As the code block shown that we convert the Pulsar functions configurations as a function spec, and so does the source and sink. Apart from that, we also define a function mesh, or we call it a mesh, which is a collection of functions and connectors connected by Pulsar topics to achieve a more powerful stream processing logic. All functions and connectors in a mesh share the same life cycle with the defined function mesh spec. All the functions and connectors are managed together which means that they are started with the mesh is created and terminated when the mesh is destroyed. So here is a typical mesh use case, and we assume a complex data processing flow, like we consume messages from an external service like MongoDB with source connector, and to process the message like with multiple functions. And then at the last, we push the processed message to another external service target like MySQL or Redis to accomplish the complex processing flow. And we can define all these functions and connectors as one mesh. So instead of using Pulsar admin or Pulsar Kato, we can now use kubekato to submit function mesh CRD manifests directly to Kubernetes clusters. The function mesh controller watches CRD and creates related Kubernetes resources such as stateful sets, service, or the HPA to run the defined function or connector. In this way, both the function metadata and the function running state was directly stored and managed by Kubernetes to avoid the inconsistency problem I mentioned before. With native, with the native support of Kubernetes, function mesh support can have the ability provided by Kubernetes, like the auto-scaling. Based on Kubernetes horizontal pod autoscaler, user can submit a CRD like with max replicas defined and to have the related HPA to be created and doing the auto scaling based on different resources and the metrics. Recently, we just upgrade the support of auto scaling to API version v2 beta 2, and which gives the function mesh the abilities to scaling not only based on the system resources like CPU, memory, or I/O, but also the matrix from function or connector itself. And furthermore, it can also be able to customize the auto-scaling behaviors. And we have provided the related APIs to use with the function mesh. So apart from the HPA, function mesh can also can be also benefit with other Kubernetes resources and the functionalities like secrets, config maps, sidecar, security context, and so on. So next we will talk about function runner. Function runner provided Pulsar function runtime per language, so it can invoke the functions and connect logic when receiving event from input topic and produce the result to output topic. And now we have self-contained function runner based on Pulsar functions runtime, and we build multiple individual functions runtime images based on stream-native Pulsar image. Each runner image contains a language-specific runtime and the related toolchains. And we published a Java, Python, and Go runner image start from Pulsar 2.7.3. And we will keep update the stream-native Pulsar image. Recently, we just moved the runner image as a rootless image, and this can help us to resolve some security issues on the cloud environment. We also released a bunch of per Docker images for Pulsar IO connectors to Docker Hub, and which can be used directly with function mesh to have a quick setup of connectors. And you can check the list of our released connectors from Stream-native Hub. And here is the link of Stream-native Hub, which is hub.streamnative.io. And lastly, we will talk about the network service. Mesh Work Service is an implementation of the Pulsar's worker service interface, and it can be used as a plugin along with the Pulsar workers. It basically forwards the functions worker API request to Kubernetes cluster and directly operates on CRD. And with Mesh Worker Service, users do not need to change the way they manage functions with Pulsar admin or Pulsar Cattle. Currently, Mesh Worker Service works with Pulsar 2.8, and we also added some useful configs to allow user customize the worker service, like disable specific API endpoint. It also allows users to manage built-in connectors by defining the metadata of supported connector. So here comes to the summary, which I will elaborate the key benefits of function mesh. We built function mesh to ease the management of Pulsar functions when you run multiple instances of function together, and the function mesh utilizes the full power of Kubernetes scheduler. It also makes Pulsar function run natively in the cloud environment, which leads to great possibilities when more resources become available in the environment. Lastly, function mesh enables Pulsar function to work with different messaging systems and to integrate with existing tools in the cloud environment. This is because function mesh run Pulsar functions independently with Pulsar cluster. And finally, I will talk about some future plans. For example, we want to add more Pulsar functions feature to function mesh, such as a stateful function. And we also plan to extend the function runner to support additional runtime like WebAssembly. Also, we would like to provide some more better tools and interact with function mesh. So if you are interested in function mesh or want to get involved to function mesh, you can come to our website, which is functionmesh.io, for detailed docs and examples. We also open source the function mesh on GitHub, which is streamnative/function-mesh. And welcome to start, fork, or posting issues and PRs. So if you want to try function mesh on your local machine, you can try with our 1K installation script from GitHub, and it will start a kind cluster on your local environment and install function mesh to the kind cluster. Also, we have provided the Helm charts to install function mesh to any existing Kubernetes cluster. And if you have any questions, please feel free to contact us on GitHub. And next, we will have a quick demo. And for the demo, we actually have an implementation of the function mesh to the production environment of Streamnative Cloud. So this demo will simply create a AWS SQL sink and a AWS SQL source. And we will try to send some messages from the SQL queue and be able to receive the messages from another SQL queue, since the Pulsar sink and the source transports the messages across the two services. So here we will have some quick config about the SQL sink and SQL source. Now we have both the SQL source and SQL sink running. And you can see the status is ready. And we will check the connect with SQS terminal. And so here we send a hello Pulsar submit message to one SQS queue. And we will be able to pull the message from another SQS queue here. Yeah, so here we are. And we will try another message. And this is the stream native. So here it is. So this quick demo is showing that we can easily to have connectors on cloud environment. And as we are done, and we will do some cleanup work to delete the sync from stream native cloud. And also we delete the source. And that's the end of this demo. And at last, if you are interested to work with us, please check our open positions from streamnative.io/careers. And we are hiring. Yeah. So that's all for today's sharing. And thanks for your time. And hope you enjoy the talk.